AM GM inequality. It is one of the most popular inequality in mathematics. In this video, our goal is to supply a proof of AM GM inequality. But the general proof of this inequality is not easy. In fact, it is far from easy. So we have attached the document in the description where you can read its general proof. And now we are going to prove the inequality for two numbers and for three numbers. AM GM inequality states that the arithmetic mean of some non-negative numbers is greater than or equal to their geometric mean. And the equality holds if and only if all the numbers are equal. If we take two non-negative numbers a and b, then the arithmetic mean geometric mean inequality states that a plus b upon 2 is greater than or equal to square root of ab. And the equality holds if and only if a is equal to b. Similarly, we can state the inequality for three non-negative real numbers a, b and c. In the most general form, we can state the inequality for n non-negative numbers a1 plus a2 up to an upon n is greater than or equal to a1 a2 up to n whole power 1 by n, and the equality holds if all the numbers are equal. Let's see the AM GM inequality at work in these examples. In all of these examples, we see that the arithmetic mean of non-negative numbers is greater than or equal to their geometric mean. So we guess that the AM GM inequality is a valid result for all non-negative real numbers. But remember, examples are not the proof. Examples may help us to build an intuitive understanding, but they can never substitute a proof. If we want to prove something in general, then we have to supply its proof in general. Mere examples are not sufficient. But as we noted earlier that the general proof of AM GM inequality is tricky and lengthy, so you can follow a link in the description. Now let's prove AM GM inequality for two numbers. For two non-negative real numbers a and b, we need to prove a plus b upon 2 is greater than or equal to square root of ab. We take some reversible steps and eventually we reach a statement which says that the square of some real number is greater than or equal to 0, which is of course a true statement because the square of any real number is always non-negative. It means by taking some reversible steps we reach the true statement. So it implies that our first statement was true. And since the equality holds in the last statement if and only if a is equal to b, so in the first statement. This completes the proof of AM GM inequality for two numbers. We prove this inequality in a backward direction. If you want, you can prove it in the forward direction, like this. In this proof, the trickier part is the starting point. How do we know where we should start from? That is why sometimes thinking in a backward direction is a better approach. Proving some statement by taking reversible steps is a very powerful strategy in mathematics. Suppose we are given some statement P1 to prove, and it is not immediately clear how to prove it. We take some reversible steps and suppose we reach some other statement Pn, which is obviously true or at least easy to prove. So the trueness of Pn would imply the trueness of P1. In other words, proving Pn is as good as proving P1. But remember, it is valid if you take all the steps are reversible. Even not a single step should be irreversible. Make sure you understand it properly. If you want to practice some problems on this technique, you can read our book Algebra Volume 2. If you are someone who wants everything in detail, in a precise way, then you are going to love our books. The links are in the description. Now let's prove the AM GM inequality for three numbers. Let a, b and c be three non-negative real numbers, and we want to prove a plus b plus c upon 3 is greater than or equal to cube root of abc. Again we shall follow the same technique of taking reversible steps, and we shall reach some other inequality that will be obviously true. But before that, let's do some substitutions that will make our work easy. We let x cube is equal to a, y cube is equal to b, and z cube is equal to c. Thus, equivalently, we need to show x cube plus y cube plus z cube minus 3xyz is greater than or equal to 0. That is equivalent to x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx is greater than or equal to 0. This factorization is standard. If you are interested in its proof, follow the link in the description. Now we multiply the whole inequality by 2 and we get the second factor equals x minus y whole square plus y minus z whole square plus z minus x whole square. This inequality is clearly a true statement because both the factors are non-negative. Thus, we have reached a true statement by taking some reversible steps. This proves the first statement. It means we have proved a plus b plus c upon 3 is greater than or equal to cube root of abc that we wanted to prove. But the work is not done yet. We have to figure out when the equality holds. Notice that in the last statement, the equality holds if and only if any of the factor becomes 0. Since x, y and z are non-negative, so the first factor can be 0 if and only if each of x, y and z equals 0. Equivalently, x is equal to y is equal to z is equal to 0. The second factor consists the sum of 3 squares, and the sum of 3 squares can be 0 if and only if each of the square is 0. So the second factor can be 0 if and only if x is equal to y is equal to z. In either case, the equality holds if and only if x is equal to y is equal to z, which is equivalent to a is equal to b is equal to c. That is the thing which we wanted to show. In this way, we have proved the AM GM inequality for 3 numbers as well. Thus, we have proved the AM GM inequality for 2 numbers and for 3 numbers. And as we noted, a general proof is attached in the description. That's it in this video. Next week, we shall practice some problems based on AM GM inequality. If this video is helpful for you, make sure you hit the like button and subscribe our channel if you don't want to miss such amazing videos. Thank you for watching the video. See you next week.